Welcome back, and in this short video we're just going to be looking at the spider diagrams on page 21, just as a bit of revision. Okay, so these are the reactions we need to know for benzene, including the mechanisms for each of these reactions. So the first reaction here we're going to look at is bromination. So this is our catalyst, FeBr3, and our bromine liquid, and its heat under reflux. Nitration of benzene, nice and straightforward. It is concentrated sulfuric H2SO4, that's my catalyst, and concentrated nitric HNO3. And this one is done at 55 degrees Celsius, again under reflux, and that's for a single substitute. If we want more than one substitute on the ring, we're going to have the same reagents, but the temperature is simply going to be greater than 55 degrees Celsius. These next two reactions, these are my Friedel-Crafts reactions. To add an alkyl group, this is alkylation. I'm going to need my catalyst, AlCl3, and a halogenoalkane. And that will add any R group on here. Now you can add any R group you like, remembering that wherever you take off the halogen, that's where you get the positive charge. Acylation, very similar. We'll use the same catalyst, AlCl3, and we're going to use an acyl chloride. And this will always make this ketone functional group. So it's a way of getting a ketone functional group onto a benzene ring. Then the phenol at the bottom of the page. Phenol, remember, is a weak acid, so it will react with sodium hydroxide at room temperature and pressure. It's not strong enough to remember to liberate carbon dioxide from carbonate, so there's no fizzing involved there, but it will react with sodium hydroxide and you'll get this O negative, Na positive, and obviously water being formed as well. If you add bromine water, so this doesn't need to be done under liquid bromine conditions and it doesn't need a catalyst, and this again can be done at room temperature and pressure, and you get this multiple substitution, so you get this 2,4,6 tribromophenol, and obviously you've also made 3 hydrogen bromide molecules, because if you remember, this is still electrophilic substitution. Dilute nitric acid, HNO3, will make nitrated products. You will usually get them substituted in the 2 and the 4 position, so you get a mixture of these two. If you raise the temperature a bit too much, you'll get multiple substitutions, so you may get some 2,4 or even some 2,4,6. Lastly, you can turn this into an ester, but you do need something a little bit stronger than a carboxylic acid. So in this case, we're going to use an acyl chloride, and I'm going to use my C double bond O Cl, but I don't need catalyst, so no catalyst is required. And you don't get the substitution onto the ring, notice, you just get the substitution here and you're making an ester. So this is an ester functional group here. It says ester. This is a way of getting an ester onto the ring. So that was a short but sweet video just looking at those spider diagrams on page 21, and that completes the aromatic notes. Make sure you've learnt those mechanisms and you understand why benzene is more stable than expected. Lastly, you need to understand the differences between the reactions of phenol and benzene and why phenol is more reactive than benzene. That's all for now. Take care. Bye bye.